In this lesson, we're going to discuss the average rate of change for a set of data. The average rate of change over a given interval is the change in the output divided by the change in the input. In math, we use symbols to represent the phrase the change in, and that's the Greek letter delta. Suppose the output is cost in dollars C and the input is pounds P. If 6 pounds of apples cost $18 and 2 pounds cost $6, what is the average rate for these apples? So I have the change in my cost, since that's the output, divided by the change in pounds, which is my input. Well, if I'm looking at two values, the change in them is really the difference of the two values. So I have 18 minus $6 divided by 6 minus 2 pounds. So I have $12 for every 4 pounds, or $3 for every 1 pound. So my average rate for these apples is $3 a pound. Okay, notice again how a rate has two units, a unit in the numerator and a unit in the denominator. The following table gives information about new hotel construction in the United States from 1997 to 2001. The first thing that we're going to do with this data is plot a scatter plot. A scatter plot is just a plot with the points, nothing connected. Okay, so the first thing I need to do is draw my axes. So I have my input, which is my horizontal axis, that's the year T, and my output on my vertical axis, which is hotels constructed. I'm going to space out my points so that I have some room. So this y-axis here is going to be 1997, and then I'm just going to go every other. When I look at my output values, I notice that I have a low of 1,047 and a high of 1,519. So I'm going to count by 100s starting at 1,000. And now I'm going to draw my scatter plot. I'm going to approximate to the best of my ability. So I notice how hotel construction increases for 1 year and then decreases for 3 years. So that is a qualitative analysis of my graph. I'm not really talking about the numbers, I'm just talking about the general shape of that scatter plot. Okay, so we're going to use the same information and we're going to find the average rate of change for the years that are below and then write the practical meaning of that average rate of change. So I'm first looking at the average rate of change between 1997 and 1998. If you remember on our graph, that's where we saw the increase. So I'm going to need this piece of information. 1519 minus 1476 hotels divided by 1998 minus 1997. So that gives us 43 hotels over 1 year. So that means that there's an increase of construction by 43 hotels per year. Okay, we're going to do the same thing for 1998 to 2001. So that's where we saw the decrease in construction. So we're going to find what the average decrease is. Okay, so we need these two pieces of information. Again, remember it's an average, so we don't need every single point. 1047 minus 1519 hotels divided by 2001 minus 1998. So that gives us a negative 157 hotels per year. So there's a decrease of 157 hotels per year. And again, we see that visually looking at the scatter plot. A set of data where the average rate of change remains constant represents a linear function. So every kind of function has a rate of change. A linear function specifically has a constant average rate of change. So that constant average rate of change is known as the slope of the linear function, and the slope is just the steepness and direction of that graph or of that function. So we have 4 different types of slope. We have a positive slope where we're increasing. We have a negative slope where we're decreasing. So those are very easy to see when we're looking at a graph. And the same thing, it's very easy to see looking at the equation. A positive number represents a positive slope. A negative number represents a negative slope. And then we have our horizontal slope, which is zero slope. So if I have a horizontal line, I'm not positive or negative. I have no steepness to my graph, so that's a zero slope. And I have a vertical slope, which is no slope. Or you may have also heard it as undefined slope, because it's all steepness, but there's no direction. So we're going to find the slope graphically, numerically, and symbolically. So graphically, we just have to find 2 points on the graph that we can read very easily. And we're going to look at the steepness and direction. So let's look at first our change in y values, how steep the line is. So to get from this point here to this point here, I need to go up 3 blocks and across 2 blocks. So my slope, which is always denoted with a lowercase m, is the change in the output, the change in y, which is 3, divided by my change in direction, or my change in input, which is 2. So again, I'm just following up and then over. Okay, let's try that again. I'm going to pick 2 points. Let's look at the steepness. I went down 2, so that's a -2. And I went across 3. Since I moved to the right, that's a +3. If I had moved to the left, that would have been a -3. So my slope is -2 over 3. Okay, we're going to find the slope of the line numerically. So again, I'm going to look at my change in output divided by my change in input. So let's look at the change in output as I go along. I'm subtracting 1, subtracting 1, subtracting 1, subtracting 1. Let's look at the change in input. Adding 2, adding 2, adding 2, adding 2. So my slope is -1/2. Okay, the next one. Adding 5, adding 5, adding 5. Adding 2, adding 2, adding 2. So my slope is 5/2. So if I'm given 2 points, x1, y1, and x2, y2, that are 2 points on the graph, I can use the slope formula, y2 minus y1 over x2 minus x1. to find the slope of the line. So I want to find the slope of the following pairs of points. And this got a little messed up, so I'm just going to rewrite the points. -3, 2, -5, -8, -3, -2, -5, -2, and then we could read the last one, -3, -2, and -3, -8. All right, so let's find the slope of the first one. So you might want to mark it x1, y1, x2, y2. So I have -8 minus a -2, so that changes to a positive, divided by -5 minus a -3. So my slope is -6 over -2, which reduces to 3. We always want to reduce our values completely. The next one, -2 minus a -2 over -5 minus a -3. So I have 0 over -2, which is just 0. Last one, -8 minus a -2 divided by -3 minus a -3, which is -6 over 0. I know I can't divide any number by 0, so m is undefined.